Welcome to The Explainer. Today, we're diving into a tool that honestly feels like a secret weapon for anyone working with data: regular expressions in SQL. You know that feeling, right? Staring at a column of just messy text and wishing you had a magic wand. Well, you're in the right place.
So, think about it. You've got this one column, right? It's filled with phone numbers and all sorts of crazy formats. Maybe product codes are buried deep inside long descriptions, or names are just all over the place. We're going to show you how to elegantly find, validate, and pull out exactly what you need from that data haystack.
Okay, so what is a regular expression, or regex as we usually call it? Well, at its core, it's really just a special way to describe a search pattern. Think of it like a mini language designed specifically for text. It's what lets you describe what you're looking for, and it makes these super complex string operations, well, surprisingly manageable.
All right, here's our game plan for today. We're going to start with the basic building blocks. Then we'll look at the core regex toolkit in SQL. From there, we'll tackle a world of differences between databases, and we'll wrap up with a really important topic: power versus performance.
Okay, section 1, the basic building blocks, understanding the syntax. So let's dive right in and look at the fundamental characters that make up a regex pattern. You can think of these as the atoms that build the molecules of your search. All right, I know this might look a little intimidating at first, but let's break it down. These are your core building blocks. So, for example, you've got the caret and the dollar sign. Think of those as bookends for your text. They let you say, this pattern has to be at the very beginning or the very end of a string. Then you have the dot, which is basically a wildcard for any single character. And these backslash characters, they're awesome shortcuts. -D means any digit, -W means any word character, like a letter or a number. You'll see how these all start to combine in just a sec. So, let's take a look at a real pattern, D4. It's super simple, but incredibly effective. Remember D, that means find a digit. And the 4 right after it just says, hey, I want exactly 4 of those in a row. And boom, you've got a pattern that's perfect for pulling a year, like 2024, out of a messy text field. Okay, next up, the core regex toolkit, functions in action. Now that we've got a feel for the basic building blocks, let's actually put them to work. We're going to look at the 3 main jobs you'll use regex for inside your SQL queries. This is where the theory really starts to become practice. You know, you can pretty much boil down most regex operations into 3 fundamental jobs. First, just finding a pattern. Does it even exist? Second, extracting that pattern. Okay, it's there, now I want to pull it out. And third, replacing a pattern. I found it, and now I want to change it into something else. All right, let's start with the first and maybe the simplest question you'd ask. Does this piece of text contain the pattern I'm looking for? For that, you're going to use a function that just gives you back a simple yes or no, a true or false. In Google BigQuery, the function is regex_contains. In most of the other big databases, PostgreSQL, MySQL, Oracle, it's called regex_like. They do the exact same thing, just with slightly different names. Classic SQL, right? Okay, but what if a simple yes or no isn't enough? What if you want to actually pull out the text that matched your pattern? Well, that's where extraction functions come in. And surprise, surprise, the names vary a bit. BigQuery calls it regex extract, while others like PostgreSQL, MySQL, and Oracle use regex subster. This is how you'd go from just knowing a year is in your text to actually grabbing that 2024 and putting it in a new column. And this is a fantastic example of the power of replacement. Check this out. Using regex replace, you can find every single uppercase letter in a string like social security number and just insert a space right before it. It's a ridiculously efficient way to clean up and standardize data that would be so tedious to do any other way. I mean, can you imagine trying to code that manually? All right, let's talk about a world of differences, because not all SQL regex is equal. And listen up, because this is a really crucial point that trips up even seasoned developers. The regex you write for one database might totally fail, or worse, work differently in another. You can't always just copy and paste. So why all the differences? Well, it's because each database uses a different underlying engine to process these regular expressions. BigQuery uses Google's RE2, modern MySQL uses ICU, and so on. And what this means for you is that they all have slightly different rules. A classic example is in MariaDB, where you often have to double escape your backslashes. So where you'd normally just write S to find a space, in MariaDB, you got to write WS. It's a small thing, but it'll drive you crazy if you don't know about it. This brings us to a really powerful and, yes, sometimes kind of tricky feature called a look ahead. Here's the best way to think about it. It lets you find something, but only if it has a specific thing right next to it. And the cool part is it doesn't include that next thing in your final result. So you're basically peeking ahead in the string to check for a condition without actually consuming those characters. It's super useful, but, and this is a big but, it's not supported everywhere. PostgreSQL and MySQL have it, but BigQuery's engine, for example, does not.
Okay, check out this fantastic example from MySQL. This really shows off what a look-ahead can do. The first part, that plus, that's simple. It just matches any word. But the second part, the look ahead, Q equals plus I assume, that's where the magic happens. That part says, hey, only match that word if, right after it, you see a space and the word I assume. And what's the result? You get only the word that comes right before I assume. It's an incredibly precise way to pull out exactly the piece of information you need. And that brings us to our final consideration, power versus performance. We've seen just how powerful Regex can be, right? But there's always a catch, and this one's a big one, performance. Using Regex is definitely not a free lunch. So here's the absolute key takeaway on performance. You know how databases use indexes to find things super quickly? It's like the index in the back of a book. Well, those indexes usually can't do a thing with a regular expression. Because a regex pattern is so flexible and can match anywhere in a string, the database often has no choice but to just read every single row in your table. That's a full table scan. And on a big data set, oh man, that can be incredibly painfully slow. Okay, so let's do a quick recap. First, regex is an incredibly powerful pattern matching language. Second, your core functions are finding, extracting, and replacing text. Third, and this is a big one, implementations vary a lot across different databases. And finally, always remember that complex regex queries can be slow because they often can't use indexes. And that leaves us with one final really important thought. Regular expressions absolutely give you superpowers for manipulating text. There's no doubt about it. But just because you can solve a problem with a complex regex doesn't always mean you should. Knowing when to use this incredible tool, and maybe more importantly, when a simpler like or some other function will do the job faster and more efficiently, well, that's just as important as knowing how to write the regex in the first place.